Same diagram. Okay, no. So first we'll do one thing. Time taken by the particle. So the particle, there's a 1. Okay, there's a particle 1, 3, 4. Okay, there's a very popular time taken. So this will always move towards. Oh, sorry, it should be. Their velocities are such that always they'll move towards each other. And finally, what will happen? They'll meet at. So how the path of the particle, it will be like this. Okay, already most of you might be knowing this concept. One more last. Okay, finally they'll meet at the center of this hexagon. This one. It's a regular hexagon. Okay, look at this. He has asked something related to circular motion because what is the path? Curved path. They don't move in a straight line. So this particular path, there's a path described by 1, 2, 3, 4 like this. They'll meet finally at center O. First, what is the time taken for them to meet? So what was the initial separation? That is equal to A. The initial separation between them is equal to A. Then what is the initial separation? Is the final separation is 0. So what is the V relative? So we'll take the any one particle 1 and 2 will pick up. So this is 1. You'll have velocity. 2, you will have velocity like this. Okay, look at some mathematics here. What can be this angle? I'm interested in this particular angle. This should be 60 degrees. Okay, I agree this. So this should be the 60 degrees. Then what is the relative velocity between them? V relative. So V relative is equal to S relative by time taken for them to meet. V relative will be V minus V cos 60 degree. S relative is A and T. So this is equal to V by 2. This is the time at which they'll meet. What is this? Time at which they will meet. If they ask you further, what is the distance? What is the path length? Distance moved by each person to meet others. So this should be equal to S equal to B into T. So this should be equal to 2A. So each person will move a distance 2A from initial point to the center O, center of the hexagon O. Okay, I think everyone knows this basic background concept. Okay, but he has asked something not like time, acceleration of each particle, because as they are moving in curved path, and look at this, what is the type of motion they describe? Constant speed. There won't be any tangential acceleration, but since they're moving in curved path, they will have centripetal acceleration. That normal acceleration is what that is being asked here. Able to grasp the tangential speed will be 0 because as they're moving in curved path, there will be a centripetal. If I call centripetal, you may think it's a So where is a circular motion? So let me call that as a normal acceleration or radial acceleration, better you call. So what is a normal acceleration? That has to be determined. So what is the formula for centripetal acceleration? We have this one, omega square r. So we should know radius of curvature, we should know its angular velocity, or and how omega and r are related by tangential speed. This v is a constant. So this omega r into omega. So further this can be v into omega. So we know v, there's a normal, I'll write it. So that we know v is a constant. Somehow if you can get this omega, we'll get that acceleration. And after getting that acceleration, we know omega will get the radius of curvature, again using the same formula, r equal to an by omega square. I think somehow we should fight with this one only. What is an? Normal acceleration. Okay, let's get into problem. T equal to a by 2v. I think that a you'll get confused. If you want, you can write it as L also. It's left to you. Now t equal to a by 2v. So what we have, t equal to a by v. I think before meeting, Olapan is asking some sort of accelerations. T equal to a by 2v, t equal to a by v, t equal to a. I think okay, two instants of time either a by 2v and a by v. Slowly we have to. Okay, t equal to, so first part I'll put it, t equal to a by 2v at this instant. So what is the separation between them? What will be the separation between them? At t equals 0, I'll make problem for our convenient purpose. Let me proceed like this. This will be v. Initial separation was a, no, t equal to 0. Finally, what happened? The separation has become something. Okay, we don't know that. I'll call that as a some s. Okay, actually diagram in fact changes for our convenient purpose. Let me take it in this way only. So what is the separation? That is this. This is at what time? A by 2v. So shall we use the same formula? V relative equal to S relative by T. What is V relative? Should be V minus. Sir, how come now you can ask your teacher like, sir, how come you are saying that it will be like this only? The V relative will be there. You look at the way they are moving. Always the velocity will be directed towards this one. So when easier this at t equals 0, no, after some time it'll be here. So it'll be here. Again you look at the distance with this. So the v relative will remain same also. So this will be v by 2 v cos 60. So this separation is what we don't know. That is s I'm calling. This time is what we know it. So this will be v by 2 2vs by e. I think s will be a by 4. Perpendicular. Okay, okay, this one. Okay, separation is this much. Huh? Okay, fine. How to get the omega? No. Just wait. I think I'm this angle correct.
Correctly, sir.
Okay, that will be correct. S equal to a by 4 is what I'm getting subtraction. Okay, now we'll go for omega relative calculation. I need a lot of space.
Why relative, sir?
How to bring omega angular velocity. Angular velocity of 1 with respect to 2 should be equal to, I'll go back to that formula. V equal to V relative equal to R
We can
relative
write
by omega
omega
relative.
equal to V by R.
Perpendicular component of velocity. So that particular formula, no? Okay, just I'll minimize all this. So we can't. Yeah. Okay, no. So this is the this will be S relative will be V minus V cos theta. S by time is A by 2V. Solving this, I ended up S is equal to 4. S equal to A by 4. I'll write it below. Okay, now component of velocity perpendicular to it. So this the same thing. Let me resolve. I'll show by red color. It'll be much easier. You can see this one. So how to get the angular velocity of 1 with respect to 2? Any formula? Omega equal to V relative by perpendicular distance. So therefore now omega relative. I'll show for one time. Remaining you can work out very easily. Okay, now omega relative should be equal to V relative by S relative. So what is V relative? Perpendicular component. So V sine 60. What is the velocity of 1? Will be along the line joining 1 and 2. Velocity of 2, its component normal to the line joining 1 and 2 is V sine 60. So what is this? This is A by 4. So this will be V 4V root 3 by 2A, or this will become 2 root 3 V by A. Okay, this what the omega relative is what I'm having here now. So can we calculate the acceleration? So what is the acceleration? Acceleration should be equal to V into omega relative. So this should be equal to omega relative. V 2 root 3 V by A. This is A normal, what is asking.
You wrote V into omega relative, sir.
Normal acceleration. This one.
How can you multiply with omega
This is what.
relative, sir?
Yeah, that's what. See, relative motion between them. You can better if you are getting confused with omega relative, write omega. That's what in the beginning I made discussion. No?
That is omega in ground frame, no, sir.
No, angular velocity of 1 with respect to 2. No?
Sir, what you wrote is A normal is equal to V into omega, no, sir. That omega is in ground frame.
Sir, and that V also should be perpendicular to R, only then we can write V equal to R omega.
Okay,
Here
I'll do
omega
one
R
thing.
into omega. Omega R
Yeah,
cannot
that's
be.
one. I'll do one thing. And omega here is out of the plane.
V is not perpendicular to the radial vectors. Nowhere it is
And
perpendicular.
tangential velocity it should be.
From the figure only we can say, sir, at no point in time it will be perpendicular. We should take component of V, sir.
Component of V.
Do component of V only, sir.
In that equation
Oh,
on the left hand side,
V
we can't
relative.
write V
Okay, okay,
omega
this one.
there.
Okay, okay, okay. V relative you mean to say here. Velocity of one with respect to two tangential to path. How much it will come?
Sir, you wrote an equal to omega square r. That equation is written in ground frame. Then omega r equal to V. That is what you did in the second and third steps. How can we write omega r equal to V when V and R are not perpendicular?
No, see, how one and two, if they are here, what is the velocity of one with respect to two? Tangential velocity along the path. Okay, that V relative. Okay, we'll do one thing. In centripetal acceleration, no? One moving with respect to two. Distance of separation, how much we are getting? Anybody, this separation correct? This S value,
Yes, sir.
A by 4 will get it. Time
Yes,
it
sir.
equal to earlier. Oh, earlier separation was A. Now after some time T. So wait. Some mistake is happened here. V relative ke S relative. So V relative, no, there's a time that will pass here. So final separation minus initial separation. I have to do some correction here. S relative or directly I brought it. Final separation minus initial separation. Or it's like it since it will be like a initial separation minus final separation. The basic formula by time. Time is what? A by 2V. So initial separation was A. Final separation was equal to A by 4. Okay, I'll do one thing. We have to calculate first. S equal to A by 4, we got it, no? Okay, I think the basics of formula I didn't apply properly. Let me, I'll put once again all this one, just only from here. When at t equal to A by 2V, what will be the separation is asking. That should be equal to, again, this will be V minus V cos 60 equal to S by A 2V. So S equal to how much will get? A by 4. Okay, now let's come for the next particular problem. In that interval of time, how much of distance it has moved here? Where we are? This S, what it will be S? It will be like a V minus V cos 60 will be relative velocity is equal to final minus initial. Okay, yeah, I'll got it. Okay, for initial minus final, we'll take it A minus S by what is the time? T. I think, can you remember V relative equal to S relative by T? So then this will become equal to, first we'll finish off this, a minus s by a by 2v. So this will become v by 2 2v by a equal to a minus s. So v get cancelled. So this will become a by 4 a minus s. So what is s is equal to a minus a by 4. 3a by 4. This is a method. Okay, what is the basic formula? V relative equal to S relative by T. So it should be like a minus, no, it will be minus of S of my VAB will become minus like a final separation minus initial separation by time. So this will become SAB initial SAB final minus SAB initial. So this is a basic formula. So and what happened to separation will decrease, no? So therefore it will become initial minus final, that one. So that's what we did. So the separation S will become now 3a by 4. Okay, let's get into the, okay, we got it now. So now omega relative is what? 2, 3. So this will become 3a by 4. How much will get it? Yeah, this will be 3a. Let me write one more step. So this will become 4v by 3a root 3 by 2. 4v by, so this will become 2v by root 3a. So this is omega relative. Okay, now let's get into the, what is that particular formula? A normal is equal to, can we, I'm doing motion of 1 with respect to 2. Motion of 1 with respect to 2. So now how to bring that acceleration is what we have to put it here now. So shall we write V into omega relative? 2v by root 3a. So this will become 2v square by root 3a. Okay, let's justify what is this particular formula. So I'm taking help of the basic circular motion. How that centripetal and tangential acceleration are related is, I'll take help of this condition. Any objections here?
How omega is equal to omega relative, sir?
The speed of, you mean to say what is omega relative? Huh?
Omega relative is omega to 1 to something like that, no, sir. That I understood. But how can we write an equal to
V
v omega relative?
V sine 60. Okay, this is 3a by 4. Okay, this is 1 and 2 at that particular instant. Is asking normal acceleration, no? You mean to say V omega relative? Huh?
Yes, sir.
Okay, we'll do one thing. What is it? We know omega. So omega square r will write it. Omega relative square r. We don't know radius. But what is a omega like a tangential velocity? What can be the velocity, tangential velocity?
I don't have doubt with substitution, sir, but we wrote an equal to v omega in ground frame. Then how can we change that to an equal to v omega relative?
Because all these are relative terms, no? This is also what happened, normal acceleration of 1 with respect to 2. So actually, the method is, I think we have some discussion. This particular omega, it will be directed here perpendicular to plane of paper. Omega, in fact, I'm showing it here, but the omega what here will be perpendicular to plane of paper. That omega into v will be normal acceleration. No? And this particular thing is what? Component of velocity is what I'm putting that one, v sine 60, this one. So here omega will be perpendicular to plane of paper. Here it will be acted like this. Of course, it passed through the axis, no? So here v and omega will be perpendicular and an will be in this direction. Omega will be perpendicular to plane containing v and an. So what is that normal acceleration? These two, multiplication of these two is what I'll get normal acceleration, or what you can call centripetal acceleration. That's what we are doing here.
Okay, sir.
There's a thing, there's a condition. This is something very important because the basic formula, like I think long back in uniform relative motion, there I explained here. When we write it, no, even S relative VAB will become SBA by T, because final separation minus initial separation. So based on that, what will happen? So this is what usually we go wrong here. Final separation minus initial separation. Usually. Since the separation decreases, no, so you go for initial minus final. Can be asked, this is something related to basic. I think you do have plenty of questions like this. The product of these two is what? A normal. Can you work out for other part? I think I did for A by 2V. You do this for A by V.